Welcome back, grade 10s, my beautiful, beautiful grade 10s. Alright, so the Lord has given us a beautiful day. Let's see, okay, what we're going to be learning today. Alright, so today we're going to be talking about special triangles. Alright, so they're not special in the sense of that they're weird, alright, and they're like little special, you know, like some of you in class. Alright, these are special triangles that we're going to be using to help us solve some of our trig equations, trig expressions, those kind of things. Alright, trig fractions eventually when you get to grade 11. Alright, so let's just dive right into it because it's quite exciting stuff, and let's see what we can do. Alright, so our first thing over here. Alright, so the first triangle that we're going to be using, okay, is the 30-60 degree triangle. Alright, so this basically, okay, this comes from, alright, an equilateral triangle. Alright, so equilateral triangle means that there's 60, 60, and 60 degrees in each corner. Alright, and I can tell you, so say I'll make that 2, I'll make that 2, and I'll make that 2. Alright, so basically all this triangle is just half of this equilateral triangle. Alright, so if I cut this in half, right, I'm going to have this triangle over here. Alright, so let's derive it from that triangle, just so you know where this comes from. So it's not like, oh sir, what are you giving me right now? Alright, so this angle, okay, is still going to stay the same. Okay, it's still the same, so it's 60 degrees. Alright, this is going to be 90. Here's my 90 degrees. Alright, and if I split this in half, alright, this 60 degree angle is going to be split in half. Okay, so it's going to become 30 in the corner there. Alright, now let's check the sides. Okay, so the hypotenuse, alright, that's still 2. Nothing happened to that. Still 2. Alright, but if I cut this side here, I'm cutting it in half. Remember, because I'm cutting this triangle in half, the equilateral triangle in half. That means I'm cutting this side in half. Okay, so what's half of 2? That's 1. Alright, so how do you think I'm going to find this side over here? Alright, I don't know what the length of this is. Alright, so I can just use Pythagoras. Alright, so if I use Pythagoras, we're going to take, let's call it side. Okay, we're going to take the square root of the hypotenuse squared, and we're going to minus the other side squared. Alright, so that's going to, and that's Pythagoras. Okay, so please always put your reasons here. Okay, it's Pythag. Alright. Okay, and that's going to be the square root of 4 minus 1, which is the square root of 3. Okay, so that side over there is the square root of 3. So at least you know where this thing comes from. Alright, the others are a little bit different. Okay, I'm just going to give them to you just so that you do remember this. Alright, so it makes it a little bit easier when you have to remember and learn this triangle. Okay. So now, if I say, okay, I'm going to give you, tell me what the sine of 30 is. Okay, without the use of a calculator. Alright, so now I have this triangle that I can use instead of my calculator, okay, to find the sine of 30, okay, because you can see there's a 30 degrees there. Alright, so if I'm using sine of 30, okay, I'm going to look at this angle over here, okay, and I must remember obviously what is sine. Sine is opposite over hypotenuse. Okay, so what is opposite this 30 degrees? Opposite, the side opposite. Okay, it's 1 over, and what is the hypotenuse? It's 2. Remember, the hypotenuse is always opposite the 90 degree angle. Okay, so that's 2 over there. Alright, so let me just, let me just go back here. Alright, and that's 2. Okay, so if I say, okay, go find cot of 60 degrees. Alright, we know that this 30-60 degree triangle has a 60 degrees in it. Okay, so I'm going to go and look at the 60 degree angle. I'm looking over here, right, and I know that cot is the reciprocal of tan. Okay, so firstly, tell me what tan is. Tan is opposite over adjacent. So if cot is the reciprocal of that, we know that cot is adjacent over opposite. Alright, okay, so we've got adjacent over opposite, which is 1 over the square root of 3. Okay, I'm hoping that's making sense. Okay, it's not that difficult, right? The only thing now is that you need to remember how to draw this triangle. Okay, so I can give you one more example. Let's say find cosec of 30 degrees. Okay, go do that quickly. Alright, so cosec we know is the reciprocal of sine. Alright, so we know that sine is opposite over hypotenuse. Okay, that means that cosec is going to be hypotenuse over opposite. Okay, so which is 2 over 1, which is just 2. Alright, nice and simple, easy peasy, lemon squeezy. Alright, let's jump into our second triangle for this lesson. Okay, so our second triangle is called the 45 degree triangle. So what do you think, which angles are going to be in this triangle? 45 degrees. Alright, 45 degrees. Okay, so this actually comes from a square. Alright, so if you look at this, if I fill this in here, this actually comes from a normal square. Okay, with units 1, 1, 1, 1 everywhere. Okay, so that's 1 and that's 1. And what they did is they just divided this in half. Okay, so remember, a square has 90-degree angles everywhere. 90 degrees, 90 degrees. So if I cut this square in half here, boom, boom, that's where my 45s come from. Alright, 45 and 45 degrees. Alright, so now how do you think I'm going to find this hypotenuse over here? You're going to use Pythagoras again. Okay, so I'm finding the hypotenuse. Okay, we know that that's going to be the square root of 1 in the bracket squared plus the other side, so 1 plus this one, 1 plus 1, and they're both squared. Okay, and that is Pythagoras. Please always, whenever you do Pythag, right, always put the reason there. Okay, you're going to lose stupid marks if you don't put it there. Okay, and then we've got 1 squared, which is just 1, plus 1 is the square root of 2. Alright, so that hypotenuse there is the square root of 2. So if you ever forget how to draw the 45 degree triangle, okay, just know where it comes from. It comes from a square. Cut the square in half, and then 45, 1, 1, square root of 2. Right, nice and easy to learn. Okay, so let's jump into it. Alright, so if I say go and find, let's say, cos of 45 for me. Go find cos of 45 without the use of a calculator. Alright, so now you're going to ask me, okay, sir, but now which 45 do I use? Okay, it does not matter at all. Alright, so if I use this 45, alright, we know that cos is adjacent over hypotenuse. Alright, so we've got adjacent over hypotenuse. Alright, so we've got 1 over the square root of 2. Alright, if you use your calculator, alright, if you type cos of 45 in your calculator, you're going to get the square root of 2 over 2. If you give me that answer in an exam paper and the question said without the use of a calculator, and you write square root of 2 over 2, alright, I'm going to mark it wrong, because now I know that you used your calculator, because your calculator does something. It's called rationalizing the denominator, okay, which you will learn, I think, in grade 11. Alright, so please do not use your calculator if the question says do not use a calculator. Right, we're going to draw our triangles. Okay, so please be careful of that, be mindful of that. Alright, you don't want to lose stupid marks because you're doing stupid things on your calculator. Okay, alright, so now if I use, let me show you, if I use the other 45, this one over here. Alright, so cos is adjacent over hypotenuse. So if you turn your head to the right, okay, you can put the triangle on its base. Alright, and we've got adjacent over hypotenuse, which is still 1 over square root of 2. So it doesn't matter which 45 you use, it just depends on what angle your head is at. Alright, okay, so if I say go find tan of 45 for me, okay, go find tan of 45, pause the video, go do it quickly, nice and easy. Alright, so I assume you've done that already. Okay, so I'm gonna use this one just for sake of convenience. Right, you can use that 45, it really doesn't matter, you'll get the same answer. Alright, so tan we know is opposite over adjacent, so I've got opposite and adjacent. Opposite, adjacent. So we've got 1 over 1, 1 over 1, which is just 1. Okay, or for better, alright, you can just say 1. Okay, I don't like to have 2 equal signs on the same line, it just looks weird. Alright, and then let's try one more. Let's say Let's say sec. Okay, go for sec of 45 for me. Okay, pause the video, go do that quickly. Alright, so sec we know is the reciprocal of cos. Alright, so we know that cos is what? Cos is adjacent over hypotenuse. Alright, so sec is going to be the hypotenuse over adjacent, which is square root of 2 over 1, which is just the square root of 2. Alright, nice and easy. Alright, so I hope that's looking fine. And now let's take a look at our third special triangle. Okay, so there's 3 special triangles that I like to use. Alright, most of your teachers will only do the first 2. Alright, because the third one, it is a bit tricky to understand. Alright, but once you get the hang of it, it's nice and easy. Alright, so if we look at the third one, the 90 and 0 degree triangle. Okay, so firstly, we see in both of these triangles over here, we have a 90 degrees there and we have a 90 degrees there. Okay, so that is essential for all of these triangles. So I need to have a 90 degrees here. Alright, but I also need to have another 90 and a 0 degrees. Alright, so I'm going to put the other 90 over there and 0 degrees over here. Alright, so now you're probably looking at me, sir, but that's not a triangle. Alright, you can't have a triangle with 2 angles that are 90 degrees and one that is 0. That doesn't make sense. Alright, yes it does, because what is that actually? Right, if I just have 2 90-degree angles and a 0 degree angle, what is that actually? It is just a straight line. Alright, so it's just a straight line. So I'm just opened up that straight line a little bit so that you can see that it can be converted into a triangle. Alright, and we can use this. Okay, it's a nice thing that we can use. Alright, so what I want you to do, okay, so if I say that this side over here is 1, alright, I want you to use your brains a little bit. Okay, what is this side length? Okay, what is that side length? Okay, it's also 1. Alright, so if this is 1, that's 1. It's a straight line. Alright, if you think of it as a straight line. Alright, and then what is this side length over here? The height of this. Okay, just remember, it's a straight line. So does a straight line have a height? No, it has 0 height. Okay, so it's 0. Alright, there's no height over there. 0 height. Alright, so what I want you to go and find for me, see if you can use this triangle. Right, I want you to go and find the sine of 0 degrees for me. Go find sine of 0. Okay, so pause the video, go see if you can do it. And let's see if you are right. Alright, so which angle am I going to be looking at? I'm going to be looking at the 0 degree angle over here. Alright, so I need to ask myself, okay, what is sine firstly? Sine is opposite over hypotenuse. Alright, so what is opposite the 0 degrees? Opposite, I'm going to go, okay, I see it's 0. Side 0, 0. Okay, and we know the hypotenuse is always the side opposite the 90 degrees. Okay, opposite the 90 degrees. Alright, so same case here. Okay, so which side is opposite the 90 degrees? Okay, so it's either that one or it could be this one. It doesn't matter, right? It could be that or it could be that. Alright, so technically I've got 2 hypotenuses or hypotenusi. I don't know what the plural is. I'm not an English teacher. Alright, so we're going to say opposite the 90 degrees. Okay, it's the 1. Okay, and 0 over 1 is always, is it 0 or is it undefined? It's 0. Alright, please go and learn that. Alright, 0 divided by anything is 0. Anything divided by 0, so anything divided by 0, that is undefined. Okay, so please don't get the 2 confused. 0 divided by anything is 0. Anything divided by 0 is undefined. Please don't get that confused, guys. Alright, and now if I say go find cos of 90 degrees for me, this is where the confusion sometimes happens. Alright, go find cos of 90 for me. Okay, so I assume you've paused the video, you've done it already. Okay, so cos of 90. Alright, so firstly I need to go find my 90 degree angle. Alright, so it does not matter, again, it does not matter which one you choose. I'm just going to choose this one for sake of convenience. Alright, so we know that cos is adjacent over hypotenuse. Alright, so which side is adjacent, okay, to this angle over here? Is it this one or is it this one? Right, because both of them are touching the angle, but now which one's adjacent? Okay, it's 0. Well done. Okay, why is it not 1? Because 1 is the hypotenuse. Alright, remember in previous videos I said that the adjacent side is the one that is not the hypotenuse. Alright, okay, so we know that 0 is the adjacent side, and then the hypotenuse is either this one or that one. Okay, so it's 1. Alright, and 0 divided by 1 is 0. Very good. Alright, now I want you to go and find tan of 0 degrees. Go find tan of 0 for me. Alright, pause the video, see if you can do it. Nice and easy. Alrighty. Okay, so let's see if we can do it quickly. Alright, so tan I know is opposite over adjacent. Okay, so opposite this is 0. Okay, and adjacent to the 0, alright, so the sides that are touching the 0 is either the 1 or the 1. Alright, doesn't matter which one it is. Alright, so we've got the opposite and adjacent, which is 0 divided by 1. Okay, and 0 divided by, 0 divided by 1, okay, is 0. Very good. Alright, now I want you to go find tan of 90 for me, please. Okay, tan of 90, I'll do it here on the top. Or let me create some space here. Let me just rub this out. Alright, so go find tan of 90 for me. Last one on this one. Okay, so again, I'm looking at the 90 degrees. Okay, and we're going to say tan is opposite over adjacent. Alright, so again, we're going to say opposite the 90 degrees. Opposite the 90 degrees is 1. Alright, and adjacent to the 90 degrees, okay, is it 1 or is it 0? Good, it's 0. Why is it not the 1? Because the 1 is the hypotenuse, right? The adjacent is always the one that is not the hypotenuse. Alright, so 0 over there. Alright, so tan of 90 is 1 over 0, and anything divided by 0 is undefined. Okay, undefined. Alright, okay, so now let's see if we can use these triangles to find angles. Oh, sorry, to find ratios, alright, in the next few examples. Okay, so now I'm not going to give you the triangles, okay, and I'm going to say go find the ratios without the use of a calculator. Alright, so ready, set, go. Okay, so pause the video, do it quickly, see if you can do it, and then what I would like you to do is please do not look back at the triangles, alright? See if you can draw them every single time without fail, without looking back at them. Alright, so I assume you've paused, you've done it already. Alright, so I see tan of 45. Alright, so ding ding ding, I see that that's a special angle that I know I have in one of my special triangles. Alright, so whatever you get, alright, you need to be looking on the lookout always. Okay, for 0, 90, 45, 60, 30. Okay, those are your special angles, alright, and in your special triangles, alright, so you need to always be on the lookout for those special angles. Alright, so you can draw your nice triangle. Okay, we know that the 45, okay, because I watch in the math dog. Alright, you've got the 90 there, we've got the 45 and the 45, 1, 1, and the square root of 2. Nice and easy. Okay, you should be able to draw that as fast as I did eventually. Alright, nice and easy. Alright, so tan of 45, quickly, we know it's opposite over adjacent, which is 1 over 1, which is just 1. Alright, so I see cos of 60. Okay, I know I watch in the math dog. Alright, I'm going to draw my 30-60 triangle that I learned. Right, there's 90, there's a 60, and there's a 30 over there. Alright, so we know that that is 2, that is 1, and that is the square root of 3. Alright, so to remember this triangle, what I used to do in high school is I used to say, okay, we know that the 30 degrees, alright, right next to the 30 degrees, okay, is a square root of 3. Okay, so 3, 30, 3, 30, they're next to each other. Alright, and the square root of 3 is not the hypotenuse. Hypotenuse is always 2. Alright, so if you get confused of where to put the square root of 3, right? I hope that helps you. That's what I used to do in school. Help me remember that easy. All right, so cos of 60, we know that cos is adjacent over hypotenuse. Okay, so cos of 60, here's the 60 degrees. I'm looking here. So it's adjacent over hypotenuse, okay, which is 1 over 2. All right, nice and easy. All right, let's look at the next few examples. Okay, sine of 0, tan of 30. Ready, set, go. All right, so I've seen you pause the video. You've done it already. You've drawn your triangles. Nice, nice. Easy peasy, lemon squeezy. All right, so sine of 0, I know that that's a special angle. I know what that triangle looks like. Okay, it's nice and thin. All right, like me. Just joking. Okay, so we've got 90, 90, and a 0. And that's 1, that's 1, that's 0 over there. All right, so sine of 0, we go to the 0 degree angle. All right, over there. There he is. And opposite over hypotenuse. Okay, so it's 0 over 1. And 0 over 1 is 0. All right, tan of 30, I know what that triangle looks like. I watch In the Math Dog. All right, and we're going to draw a nice triangle there. There we go, and that's 30. Next to the 30, I always know it's the square root of 3. Right angle, 60, 1 and 2. Nice and easy, nice and quick. All right, so I'm looking at the 30 degree angle over there, so tan of 30. All right, so tan I know is opposite over adjacent. Okay, so I've got 1 over the square root of 3, 1 over the square root of 3. Okay, I'm hoping that's getting better now. You're getting to draw these triangles a lot quicker. All right, hopefully you guys are memorizing them already. And let's get into the next ones. All right, ready, set, go. All right, so assume you've done it already. You've paused the video, and let's get into it. Okay, so I see, ding ding, there's a 90. All right, so I know which triangle that is. That's my 0, 90 triangle. All right, I'm gonna draw it quickly. Boom, boom. All right, I know there's 90 there, there's 90 there, there's a 0 there, there's a 0 there, there's a 1, there's a 1. All right, so cos of 90. All right, so if I look at this triangle, I go to my 90 degree angle, and I see, sorry, let me just get my pen here. All right, so we've got cos of 90. All right, so I know that cos is adjacent over hypotenuse. Okay, so again, which side is adjacent to this 90? Okay, is it the 0 or is it this 1? It's the 0. Why is it not the 1? Because the 1 is the hypotenuse. All right, so the adjacent side is always the one that's not the hypotenuse. All right, okay, so we're going to say adjacent, which is 0, over the hypotenuse, which is 1. Okay, and cos of 90 is equal to 0. Okay, now looking at sine of 45, I know that that's a special angle. All right, so special angle, special triangle, I know I'm going to have my 45, 45. Okay, 45, 45. Okay, I'm going to have the square root of 2, 1, and 1. All right, so sine of 45. Okay, so I'm going to go to the 45. There he is. All right, and I know that sine is opposite over hypotenuse, so it's 1 over the square root of 2. Nice and easy. Alrighty, okay, let's get into the next few examples. Alright, let's look at that. Okay, quickly, ready, set, go. And this is going to be our last example for today. No, second last. Sorry, guys. Alright, so I assume you've done it already. Alright, so now I just see I've got my ratios, my trig ratios, busy multiplying with each other. Alright, that's not going to make me scared or anything like that. So don't worry about that. I see something new. I'm not going to get afraid. I'm not going to fear. Right, so I see a cos of 60. I know that's 60. Okay, and I know that 30. I know which triangle that 60 and 30 is in. Alright, so I know I'm going to draw my triangle. I know that that's 60. I know that's 30. I know that that is 2. That is 1. And that's the square root of 3. Alright, so cos of 60. Okay, I'm looking at the 60 degree angle. And I know that cos is adjacent over hypotenuse. So I know that that is 1 over 2. Multiplied by. Alright, so I just found cos of 60. Cos of 60 was a half. Now I'm going to say multiply, multiply, and sine of 30. We know that sine of 30 is opposite over adjacent. Alright, which is 1 over 2. Alright, now multiplying fractions. You guys love doing that. Alright, so we always say top, top, bottom, bottom. Alright, 1 times 1 is 1 over 2 times 2, which is 4. Alright, nice and easy. Alright, so I see that there's another cos of 60 here. Alright, so I do not have to draw this triangle again. Okay, so nice thing for you in the exams, every question you don't have to draw the triangle again. Once you've drawn the triangle, the special triangle, you do not have to draw it again. Okay, so that's nice for you guys. Less work for you. Alright, so I already have that triangle. Alright, so I'm going to use that triangle for this cos of 60. Alright, but I see I've got a sine of 45 as well. Okay, but that's a different triangle. Alright, so I'm going to use a different triangle for that. I know that because in the math dog taught me. Okay, 45, 45. That's 1, that's 1, that's the square root of 2. Alright, so sine of 45, I'm looking at the 45 over there. Alright, looking at that 45. Okay, you can use that one as well, doesn't matter. Sine is opposite over hypotenuse, so it's 1 over the square root of 2. Multiplied by, now I'm going to use this triangle that I drew before. Cos of 60, looking at the 60. Alright, so cos is adjacent over hypotenuse, so it's 1 over 2. Alright, now what I want to say to you, whenever you have square roots in your denominator, alright, please be sure that when you put it in your calculator, you do not put that answer down, especially when they say do not use a calculator. Alright, because what your calculator is going to give you is it's going to give you square root of 2 over 4, I believe. Let me just double check that on my calculator. Square root of 2 multiplied by a half. Yes, it's going to give you the square root of 2 over 4. Alright, and that is what my calculator gave me. Okay, but if I put that down, okay, my teacher's going to mark it wrong. Okay, so how do I multiply fractions normally in my head? Alright, top, top, bottom, bottom. Alright, so 1 times 1 is 1 over what is square root of 2 multiplied by 2. Okay, some of you guys are saying 4. Okay, it is just 2 times the square root of 2. I can't multiply in there. I can't get 4. Alright, so I'm just going to leave it as 2 times the square root of 2, which is just 2 squared 2. Alright, okay, hoping that's making sense. Hoping it's starting to look nice and easy. Alright, and let's do our last two examples for today. Alright, so I want you to look at this. Okay, so whoa, so I see I've got 120. I've never had to do. There's no 120 in any of the triangles that we had to draw. So now what, sir? Right, you're 225, sir. What the heck? 300, yo, sir. I'm getting scared now. No, you don't get scared. Right, never get scared in maths. Okay, don't fear. We tackle it head on. All right, so we see we've got something new here. Right, but do you remember the last video that I posted? Right, about the 180-degree rule. Alright, please, if you do not know what I'm talking about, please go and watch that video before you do this sum. Okay, otherwise you're going to be lost completely. Alright, so in that video, we taught you how to do the 180-degree rule. And when do we use the 180-degree rule? When I've got angles larger than 90 degrees. Alright, so if I've got larger than 90 degrees, I'm going to do my 180-degree rule. Is this bigger than 90 degrees? Yes, it is. All right, so let's analyze what's happening here. Right, so let's tell me cos of 120. Right, where am I in my Cartesian plane? Am I in quadrant 1, 2, 3, or 4? I'm in quadrant 2. Very good. All right, I'm in quadrant 2. I'm there. All right, so now what is cos in quadrant 2? Quadrant 2 is negative for cos, so I can say negative. All right, and what is that other thing I need to ask myself? Okay, I need to ask myself, how far is 120 from the closest horizontal? Alright, the closest horizontal in this case is the 180. Right, so basically what I'm asking you is, how far is 120 degrees from 180 degrees? Okay, it's 60. So how far? Okay, is 180 from 120 or 120 from 180? It's 60 degrees. So instead of saying cos of 120, I can say cos of 60 degrees. All right, multiplied by sine of 225. All right, we know where am I? First thing I need to ask myself, where am I? Okay, 225 degrees. All right, which quadrant? I'm in quadrant 3. All right, so sine is what in quadrant 3? Positive or negative? Sine is negative in quadrant 3. So I can say negative sine of Alright, but now let's check this 225. Alright, so how far is 225 from the closest horizontal? Alright, what is the closest horizontal? It's the 180 degrees horizontal. Alright, so basically what I'm asking you is how far is 225 from 180, and that is 45 degrees. Alright, that's looking nice now. Why is it looking nice? Because I see I've got special angles now. Alright, I've got a special angle of 60, I've got a special angle of 45. And what does that mean about my special angles? I can draw special triangles. Awesome. Alright, so I know my 60 triangle. Alright, because in the math dog taught me. Okay, I've got 30 there, square root of 3, 90, 60, 1, 2. Alright, and I've also got a special triangle of the 45s. Alright, so that's 90, that's 45, that's 45. I've got 1, 1, square root of 2. Nice and easy. Alright, so now let's go look at that 60 degrees. Alright, I'm here, I'm looking at the 60. Alright, and I see that cos, and I know what cos is. Cos is adjacent over hypotenuse. So I've got negative 1 over 2 multiplied by negative. Now let's look at that 45. I'm looking here. Alright, that angle there. Okay, sine is opposite over hypotenuse. So I've got 1 over the square root of 2. 1 over the square root of 2. Nice, nice. Now just multiply fractions. Okay, firstly, what is a negative times a negative? It's a positive. So I'm going to end up with a positive answer here. Right, and top, bottom, bottom. What is 1 times 1? It's 1 over bottom, bottom. I've got 2 times the square root of 2, which is just 2 the square root of 2, like we did in the previous example. Alright, so I want you to go look at this example here, the second one. Okay, and I want you to see if you can do it all by yourself. Alright, so I assume you've paused the video, you've done it all by yourself. Alright, so this 45, okay, does it look normal? It looks fine? Nice. Alright, so that looks fine. But now let's look at this one. 300. Yo, that's a big number. Okay, is it bigger than 90? Yes, it's bigger than 90. So that means I can use what rule to reduce it, to make it smaller? Right, I can use my 180 degree rule. Nice. Alright, so let's just write the tan again. Okay, so tan of 45 stays exactly the same. I'm going to leave it like that. Multiplied by, if I say 300 degrees, where is 300 degrees? 300 degrees is in my which quadrant? Fourth quadrant. Nice. Okay, so I know that in the fourth quadrant, sine is what? Sine is negative. Alright. And now I need to ask myself, how far is 300? Okay, so it's negative sine. How far is 300 from my closest horizontal? Which one is the closest horizontal? The 180 or the 360? It's the 360. Very good. Alright, so 360 is closer to the 300. Alright, and how far is that 360 from the 300? 60 degrees. Alright, so instead of saying sine of 300, I can say sine of 60. So negative sine of 60 is equal to sine of 300. So I just want you guys to just take note of, okay, cos of 120 and negative cos of 60. This is just saying the same thing in a different format. Okay, same thing with sine of 225. Okay, I'm writing in a different format, and that different format is negative sine of 45. So it's still the same thing. I didn't change anything. They're equal to each other. Alright, same thing with the sine of 300. Sine of 300 is equal to negative sine of 60. Alright, so if you put sine of 300 into your calculator, you get equals. Okay, it should give you the negative square root of 3 over 2. Alright, and if you put negative sine of 60 in your calculator, you should also get negative square root 3 over 2. Right, so you can see that those are just equal to each other, different format though. Okay, so now let's look at this. Now I've got special angles. Nice, I know the 45, I know the 60, I know where that goes. They've got my special triangles there at the top. Okay, so tan of 45, looking at the 45, tan is opposite over adjacent, opposite over adjacent, which is just 1 over 1. Right, multiplied by negative. Okay, so negative sine of 60. Here's the 60. Sine is opposite over hypotenuse. So square root of 3 over 2. And please don't forget about that negative, guys. A lot of guys forget about these negatives that are attached here. Okay, don't forget about them. Alright, so now we've got 1 multiplied by negative square root 3 over 2, which is negative square root of 3 over 2. Alright, so that's nice and simple, guys. I hope that's making sense. I'm hoping you guys are catching it now. Alright, and I hope that this video has helped you guys to understand a little bit more about your special triangles. Alright, so please memorize those special triangles. You're going to be using it up until matric. Alright, so please, guys, you need to memorize this stuff. Alright, cool, guys.